Hello friends, welcome to my educational channel GravityTech. In this series, we will cover data structures using C language, which basically includes a stack, queue, linked list, which includes singly linked list, doubly linked list, circular linked list, trees, graphs. Okay. If you like the video, please do click on the like button of the video and subscribe to the channel to get updates about the new videos. Also, share it with other students too so that it will help them as well. Okay. Now let's see what are we going to cover as a part of this thing. So what are the session objectives? So the session objectives like to understand what is stack, what are the basic operations we perform on the stack, what are the general algorithms to implement the stack operations, types of the stack, applications of the stack, and what exactly are we going to cover as a part of the next session topic. Now, what is a stack? Okay, so a stack is basically a linear data structure. So there are two types of data structures, linear and non-linear. Linear means a data structure where we store the data in the sequential form or in a line maybe, right, where you can traverse one by one, right? But when we say non-linear, non-linear are the data structures where we do not basically store the data in the form of linear. Non-linear in the sense the tree, graph, right, where from one element you can basically go to the multiple elements. But in linear data structure, from one element you can only go to the another element, not to the more than one element. Okay, so stack is a linear data structure which basically in which the insertion of a new element and removal of an existing element takes place at the same end, represented as a top of the stack. Okay, now see, so it is basically what a linear data structure that follows a particular order in which the operations are performed. Okay, now since the insertion and deletion both operations on the elements happen at the same end, it is required to maintain the pointer at the top of the stack, okay, which is basically the last element to be inserted because we can access the element only on the top of the stack. See, so now this is how the stack looks like. Assume stack as maybe kind of a bucket, right? Or maybe a kind of let's say let's take an example of chairs, right, lying on one other. If you have the chairs lying on one other, right, if you have arranged let's say 10 chairs, one two three, one on other, right, the very first chair which you have kept at the bottom, that was the chair which you kept at the first, right? So and when you want to remove the first element of the stack, you will have to basically remove all other elements and then remove that one, right? Correct. So stack is such a data structure where when we insert the elements, we insert element on the top only, and when we remove element, we also remove the element on the top only, from the top only. So top, when you insert the element, let's say earlier at the beginning, right, the stack is empty. When you insert the element A, the top will point to A. When you insert another element, let's say B, the B will go first and then top will point to B. When you insert the third element C, the top will point to C. Now, when you inserted three elements, right? See, the A is the element which you inserted very first. Then B is the element which you inserted next. Then the C is the element which you inserted third. Now, when you want to take out the elements, right, you really cannot remove or delete B and A elements unless you remove the element C. So very first, if you want to remove the element, if you want to delete any of the elements from the stack, you need to remove it from the top only, right? So what does that mean, right? See, if you want to remove the element A, you will first remove C, then you will remove B, and then you will remove A. What does that mean? That stack is a kind of last in, first out data structure, right? Last in first out matlab the one which is inserted last will be the one which you will take out first, or philo means first in and last out, so whichever comes goes first, right, will basically come out last, right? So LIFO or philo is the data structure basically what the stack follows. See, so LIFO or FILO, last in first out or first in last out order. So remember, so the stack is kind of LIFO or FILO data structure. So where do we use the stack in real life? In real life, we use the stack when we do undo and redo in any of the Excel spreadsheet, right? You might have worked in the Excel spreadsheets, done some uh, record keeping, right? Or maybe some kind of calculations and all, right? Whatever may be data, right? If you are keeping into the Excel sheet, right? At that time, if you do something wrong, you will actually do undo, right? Control Z. That means it goes back, right? If you want to actually see what exactly you reverted, right, that will be redo. So undo, redo, all these operations, basically how you are able to do it, right? Let's say you performed something uh steps, some 10 steps uh, before, right? And then you want to go, if you want to revert all those 10 steps, you will actually do undo, 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 right, 10 times. What does that mean? In a stack, all those instructions were actually kept. The very first instruction what you did, very first change what you did, it actually went to the bottom of the stack. Then the next instruction, on the top of that, top of that, top of that. That's why the last recent instruction what you, or a recent change what you did in that Excel sheet, basically goes on the top of the stack. And when you remove that, right, that's why actually it applies that to the undo changes, right? When what you perform. So undo and redo are the real time examples of the stack when we use. Also, when you browse something on a browser, right? If you browse something on browser, you go back and forward, right? That is also kind of a stack operation you do. When you solve the expressions, when you, let's say, do 2 plus 3 star 5 divided by 8. Now this expression, though you, when you do it uh, by your hand, right, you will be able to do it like first do the divide, then multiplication, then the plus. But when it is being performed by the computer, in a computer system, it basically first converts that either into the prefix or postfix, and then uses the stack to implement it, or to solve it. So that's how stack is. Basically, stack is what? A linear data structure that follows a particular order in which the operations are performed. Okay. Now the always elements are inserted on the top and elements are deleted from the top, right? Now top is the one which will basically tell you from where to, from where to delete the elements and to where it is inserted. Okay. Now to insert any element in a stack, we use push operation. What do we use? Push operation. And to remove any element from the stack, we use the pop operation. Remember, these are the operations which basically we perform on the stack, right? Now, so push is basically, if you go next, right, see, so the basic operations what we actually do, right? So the basic operations are like, we can see push. Push means what? To insert an element into the stack, we use push operation. Pop. Pop is the operation which we use to remove an element from the stack. Top. Top is an operation basically we use, which basically returns the top of the stack. Right now, when you run this, when you maybe invoke the top operation, right, what it will basically simply give you, it will just simply return where the top is, right, so that you understand from where to remove, right, or where to insert. Then is empty. This will basically tell whether the stack is empty or not. It will return true if the stack is empty, and if it will return false if the stack is not empty. Size, it will basically tell you how many number of elements are there into the stack, right? So basically returns the size of the stack, right? So see, so these are the main operations. Push, pop are the main operations. Stop, is empty, and size are something which may be optional, and then you may basically take care inside your logic itself. But it is always good to have the separate functions for all these, right? Now see, so what are the algorithms we do use, right? We are going to see this practically. Okay, so I'm gonna code it practically how to implement the stack Okay, so we'll look at that. But before that, what exactly algorithm you will use, right? Now, if you want to push the element, push means you want to insert the element into the stack, right? That means adds an atom to the stack. So what exactly algorithm, right? Very first thing, when you are inserting something into the stack, right, you will need to check whether the stack is full. If it is full, you won't be able to insert the element into the stack, right? So that's why when the stack is full, it is said to be overflow condition, right? Let's take an example of bucket, right? In a bucket, if you are pouring the water, and now if your bucket is full and if you are trying to pour more water, what will happen? It will basically overflow. Correct. So that's what overflow condition is meant. Means something is already full, and if you are trying to pour or put or insert something into that, right, extra thing, that will obviously come into the overflow. So that's why when you say if the stack is full, say return, cannot enter anything, right? And maybe end. Else, what do you need to do? Okay, now the stack is not full, means there is a place where new atoms can be inserted, right? So just increment the top and insert that into the stack, right? That's what the push operation is going to be. Now what is a pop means remove, right? When you are removing it, very first thing what you need to check, is it a uh, is the stack empty, right? If the stack is empty, if you are trying to, let's say your bucket, let's again take an example of bucket, right? In a bucket there is no water. In a bucket there is no water, and if you are trying to remove the 1 liter of water, will you be able to remove it, or will you be able to take it out, right? No. Why? Because there is nothing to remove. That means underflow condition. Correct. So when you want to remove something from the stack, the atoms, you basically need to check whether it is empty. If it is empty, do not do anything, right? And if it is not empty, what does that mean? Yes, you have something which you can basically what? Remove. So when you want to remove, right, what does that mean? Top will come down. So decrement the top and then return the value of the earlier one, right? That's what the pop means. Now, what the top function will do? It will simply return the top of the stack, right? See what it will do. It will just return the top element of the stack. Correct. Now is empty. It will check whether the top is what? Empty or not. Means top is less than one, then return true. Otherwise false. Correct. Now, what are the types of the stacks? There are two types of stacks. One is what? Fixed size stack, and other one is what? Dynamic stack. Now what is a fixed size stack? Fixed size stack means what? Where the size of the stack is already fixed and a static. That means when you start your implementation, you know what is the size of stack. Let's say if I go with the stack of integers of 10, right? What I will do, I know in that stack of integers, right, only 10 integers will fit. So if I try to put the 11th element, I won't be able to do it. So that's what means, right? So the size of the stack is already fixed and known before the execution. Stack cannot grow dynamically. You cannot grow that beyond the existing limit. If the stack is full, an attempt is made to add an element to it, then overflow error will occur. Obvious. If the stack is full and if you want to try to insert any other element into that, right, it will basically give you the overflow error. If the stack is empty and an attempt is made to remove an element from it, right, from the empty stack, if you want to remove something, right, it will basically give the underflow error. So this type of stack is basically implemented using what? Static array. Remember, this will be always implemented using what? Static array, which we are going to see it practically now. Okay, which does not allow easy resizing of the stack. That means fixed size. Okay. Now what is a dynamic? Dynamic means that stack can grow and shrink dynamically. So if you, let's say, if you do not have any elements, right, the stack will be empty and then there will be no elements inside the stack, so no memory will be allocated. But let's say if you want to insert new element into the stack, you just allocate that memory inside the heap and then add that element into the stack. Then the next again add, create. So how that happens? Insertion of an element in dynamic memory, how it happens? Dynamic stack allocate the memory for that element and then insert that element into the stack, allocate the element memory and insert, right? And if you want to remove, right, what does that mean? Just maybe remove that element from there and free that memory so that it will be it can be easily used by other other programs processes, right? So that's how it means it can grow and or shrink dynamically. When the stack is full, it is automatically increases its size to accommodate the new element. That's what actually I said, right? Even if the stack is full, you can easily add new elements into that by just maybe allocating a new piece of memory. Okay. When the stack is empty, it basically decreases its size. That's what actually I said, right? And this type of stack is basically implemented using the linked list that is dynamic. And we are going to see that as well, as it follows a easy resizing of the stack, right? Now, let's let's see the practical examples of the stack, right? Practical examples of the stacks are like we will see how the stack of integers is implemented. Very first thing we will see static implementation and then the dynamic implementation. Now let's look at the static implementation of the array. Okay, I'll maybe just quickly take the editor here. So here is the id. Now let's maybe try to keep it, right? See, so very first thing what we do, we include stdio.h so that whatever printf and scanf are kind of built-in functions are we going to use, those will be easily identified by the compiler. Now let's try to have some comment out here, right? Or maybe comment should be here, right? What exactly this program is going to do? This will be a fixed size stack implementation, right? Fixed size stack implementation of integers. Now we know when it is fixed size means what? It has to be using arrays, right? Now what we need top, we need push function, we need pop function, we need a function to display the tag stack, right? We need a function to know the size of the stack. We need what else we need? We basically need the function to check whether the stack is empty, right? We also need a function whether to check if stack is full, correct? Because in a fixed size, right, there is an overflow condition can happen. So this is for overflow condition, right? And this will be for underflow condition. Now let's look at now what exactly we can do, right? Now what we need, let's maybe try to keep it. Let's start with the int main, right? The main function, what is required, right? This is the syntax of main. See, before writing this, it is assumed that you know the C language very well. Okay, now let me just maybe save this to some other name, right? Static stack, right? Now I just given this name to the file. Now see, very first thing, to store a stack you will need a stack, right? So stack of integers, let's say 5. I'm just maybe taking the stack of 5 integers, but instead of having 5 here, right, I can use the preprocessor has define max size, right, is 5. What does this mean, right? This I can use this macro anywhere. Let's say now instead of this 5 I can use max size stack macro, right? Now this is one thing. Now what else I am going to need? I am going to need top, right? Right. So top to track where how many elements of this stack are already are filled. So very at the initially, right, top will always point to where -1 because there are no elements. When we say in this stack there are elements, right, what does that mean? Even if there is one element, top will become what? 0. Why? So that the element will be a zeroth index element, right? Since there are no elements in the stack, so top is what? -1. Correct. Then what are you going to need? Right. Let's maybe uh, try here, right? So what we should do? we should basically give user some menu. Okay, let's give a user some menu, right? What user will have, user will have these options, what exactly he wants to do, right? So let's maybe write a function int menu, right? Int menu, what it will do, right? It will have a choice, correct? It will have a choice, let's say with 0. So we are going to give a user an option what exactly he wants to do with the with the stack, right? What operation he wants to perform, right? So we will basically give a printf. Let's give this as a menu so that user sees what exactly he can do, correct? So menu, I'm just adding new line, new tab, right? Just for the more formatting purpose. So printf, right? So one, push an element to stack, correct? So very first thing, if the user enters one, that means what, user wants to push the element to the stack, right? Then let's maybe copy these and then paste here. If the user enters two, user want to pop an element, that means delete an element, right? Then let's maybe have three, right? What does that mean, right? Size of the stack, it will tell what exactly the current size of the stack, right? Then if the user enters 4, user will basically have an option to display the stack, correct? Display the complete stack. And in case if 0 is entered by the user, what does that mean? User want to exit, user doesn't want to do anything, correct? So that's how it is. Now let me maybe, so we will ask user what is the choice, correct? So we will ask user to enter the valid choice, right? And choice, valid choice is what, 0 to 4, correct? So user will basically enter the choice. When user want to enter the choice, we use scanf, right, to read the option. So %d, and where are we going to read it? In the choice, correct? Now let's say this is in this choice we are going to read. And but see, users are always nasty, right? User may not enter always in between 0 to 4. So we need to basically make sure that user has entered the correct choice, right? Choice is greater than 4, or choice is less than 0. If user somehow enters choice less than 0 or greater than 4, then we need to basically give user an error message that user has entered incorrect choice, right? Incorrect choice, enter the correct one, correct? So that's how it will basically give. Now why I'm using do here, right? I should basically use do while. Why? Because user may not enter the correct value one time, two times, three times, but at certain time he will have to enter the value to get the correct answer, right? So the same thing, this loop will enter unless user does not enter, until user does not enter the correct choice, right? And then once this is done, right, we will return a choice from here. Now what this function is going to do, what this function is going to do, right? This function will basically provide the menu, and then it will return what exactly the choice the user has entered, right? Now, so where that choice we will have to basically keep it here, right? Let's int choice is equal to 0, correct? Now what we need to do, we should basically have a switch case which will invoke this function. Now what this function is going to do, this function, you see what this statement will do, this will call the menu function, it will come here, it will invoke everything, it will return some integer here, one of the choice, either 0, 1, 2, 3, 4, and then that will be stored into the choice, right? Or you may not need the choice here, right? We may not need it, right? We can just maybe ignore, we can just maybe use directly this into the switch. Now let's see. Now whatever value is returned, let's say in case menu returns 1, so it will go to the case 1, correct? If if user selects 2, it will basically come to the case 2, correct? If user selects 3, it will come to the case 3. If user selects 4, it will come to the 4, correct? And if user returns 0, what we should basically check here, right? We should also have here a 0, right? Let's say, so when case is equal to 0, right? So that's how it is. For the last, we don't need a break. We can have it. Okay, now let's maybe try to put it one by one. Yeah. So very first thing, what push? Very first thing is what? We need to push an element. Correct. So for that, what we will do, we will ask user to enter the element, right? So what we are going to ask user, enter the new element, right? So, but before that, what we should check? We should check, see, the very first thing what we should check is like this, correct? So if stack is full, do nothing, correct? Else accept element and insert into stack, correct? So very first thing is stack is full. So we will basically write a function. If is full, let's maybe write a function is full, right? If it is full, right, we will give some error message. What error message that should be? Let's say overflow, right? This is overflow condition. Stack is full and new element cannot be added, correct? So this is how it is going to be. But if it is not full, what does that mean? We can easily enter it, right? The new element. So we should basically ask user, so new element, right? Maybe let's say element. So ask user, right, what element user wants to enter. Enter the element to be inserted or pushed. So when user want to enter the element, we basically use the scanf, correct? Let me increase the font in case maybe, right, if it is not that visible, right? So I just increase the font. Yeah. So see, so scanf, right? When user wants to enter the new element, we should basically ask user to enter the new element like this scanf, and then the new element will go here. But we basically need to push that now, right? So we should basically write a push function. Now push, but where to push? We need to push that on the stack. What we need to push? We need to push the element, correct? And what exactly to be changed? Top. Why I'm using address of operator here? Because I want to pass this as a pointer, okay? And I want this as to be a pointer too. And then this will be element, because I want to change this. When you insert the new element, top is going to change, right? Top will increase. Now let's say there are already two elements in the stack, and then when you insert the new element, top will now point to the third element. That what does that mean? Top will basically increase. And then if we do not pass the pointer here, right, address of operator here, right, as a pointer, then whatever local changes are done into the push to the top, those will not be visible in this function, right? To make those changes in the actual copy, we should basically pass the pointers. Correct. Now we will be passing the element and then the stack. Now let's maybe write the function, right? Now what are we going to write is, let's maybe do it like this way. So for push, we don't want to return anything, right? There will be a push function. Then this is going to be what? Int star stack. Correct. So that was what it is going to be. Then let's say new element, right? And then int star top. Now, what exactly are we going to do? Because we know it's not a full. It is not full, right? So when you enter the new element, what will happen here? You need to increase the top, and then you need to add the element there. So what it will be, right? See, so start top should be equal to what? 1. That's what we should do. So this is simply also means star stop is equal to star top plus 1. What does that mean? Now top is actually pointing to the next element, and we are good to have insert the new element. So that's done. What does this mean? We increase the top. Now let's say there are only 2 elements in the top stack. Now top will become point to the next element, which is empty, and then in that empty space we are entering the new element. So now top is pointing to the new one, right? But somehow I think here when we coded, when we added is full, right, we basically we did not write this function. So maybe let's write down, right, what is full means, right? So here we will pass the top. Correct. So is full condition. Correct. What is full is going to return? Is full will return either true or false, right? It will be return true if the stack is full. If it will return false if the stack is not full. See, so it should basically return boolean value, because bool is the one of the data type. Correct. Is full, then what it is, a it is going to be in top, which you are going to accept this as a parameter. And then if top is equal to max size minus 1, then return true. Why max size minus 1 or return false? Because see, the array indices starts with 0. So if max size is 10, what does that mean? In an array, in a stack array, right, the elements will basically from 0 to 9. So you should basically check whether it is pointing to 9 if max size is 10. If the static array is of, let's say, 20 size, then there will be what? 19 elements at the max. So top is equal to what? Max size minus 1. If it is, then the stack is full and no other element can be inserted. But if it is not, it will return false. So now this is what we got it as a push, right? Now let's look at the pop. So what will be pop, right? Pop means remove the element. So when user selects 2, right, it will basically come to pop. Now if you look at the pop, what will be the algorithm? So you will first check whether it is empty. If empty, do nothing, correct? Because this will be underflow. Else, remove. Else what we'll do? Remove the element. Now when we want to remove the element, what we will do? We will decrease top, correct? Will decrease the top and it will return the element, return the popped element, right? Now let's see how to implement that. So the very first thing what we will check, if we will write the function is empty, correct? Is empty, but what is empty? We should basically check whether top is minus 1, right? If it is if the stack is empty, we will basically print some message, correct? Underflow. What does that mean? Stack is empty and cannot be removed, right? What cannot be removed? Element cannot be removed, right? So that's what it is. Now, but if it is not empty, that means we can remove, right? Now, when we say we can remove, printf element removed or pop is what? Percent %d. But percent %d means what? Pop, right? Pop will be what? You need to basically pass from where you want to remove the element and what is the top, correct? Now, so as a part of this, we need to define two functions, isEmpty and pop. Now let's try to define those functions here, right? So here int is empty, correct? And then it will be simply what? Top. Now when we say stack is empty, when top is what? -1, right? If top is what? -1, then return true. That means if top is not pointing to, let me, 0 or any of the values, right? What does that mean? There is no element in the top stack. That's why return true. Else return false, correct? So this will basically return true or false. If it will return true if the stack is empty, it will return false if the stack is not empty. Now what are we going to write in terms in a pop function? Let's say pop, correct? So it will be what? Int star stack and int star top. Now when I say here int star top, right? Am I passing address of top here? I'm not. So I basically should pass the address of operator. Why? Because when I'm trying to capture that into an pointer, right? I should basically pass the address of operator, right? Now let's see. Now pop means what? It's simple. You need to basically int popped element is equal to what? You should basically just have stack of star top and then star top is equal to star top -1, correct? Done. So let's say in your stack 12, 23 and 45 are the elements, right? So basically top is going to point to where? 2. Why? Because 0th element, first element and second element. Now when you want to remove, right, you will remove it from the top. So when you remove from the top, right, you will return 45 and the stack will have 12 and 23 only. But now top, if top keeps on pointing to, it will still point here. So we need to remove top. We need to reduce top as well, right? So top should basically become 1. So that's why star top is equal to star top -1. And then the first element before before decreasing top, right? Decrementing top, we are basically we are storing the element of the top somewhere into this. And then we need to return a popped element, right? This will be a pop function. Yeah. Now this is what the pop means. The third, it will basically give the size of the array, right? So it's sorry, size of the stack. It's very easy. So printf. So very first thing you should basically check whether the stack is what? Empty, right? Is empty. So if it is empty, is it the way we use the is empty, right? No, we are having a top there as well as a parameter, right? If it is empty, you should say printf stack is empty, so size is 0. Correct? Or rather, why should basically we have it here? Correct? We should basically, rather than have it like this, printf stack size is %d. Now what it will basically give, right? Uh, let's say size function, size and top. Correct? Let's maybe try to define a size function now. When we try to write a size function, we will put it here. Let's say it's going to return size, let's say top. Correct? We will check if is empty top. If it is empty, return 0, right? Else return top plus 1. Why? Let's say if your stack is like this, so top will be how much? 2. But how many elements are there? 3 in actual. So you should basically return what? Top plus 1. Correct? So that's how it is. Yeah. Or you might not need to check here, right, what exactly it is. You would basically always simply, you can say, return top plus 1, right? Not even need to check whether it is empty or full, because if it is empty, top will become -1 and -1 plus 1 will become 0. So if it is empty, it will return 0, right? That's what it is, size means, right? Now the next is what? Display. Now let's try to display the stack, right? Now display stack, it will basically, we can have, since we are not going to make any changes into the stack, right, we can simply write it here and then int top. Correct? Now how the display function will look like, and then display function doesn't return anything, right? So let's say display function, try to write it here, right, where it is. Yeah, after this, see, I'm just maybe trying to write each and every function on the top of this. So void display stack. Correct? So int stack is the one when win top we are going to have it, right? So very first thing we'll check if it is empty. If it is empty, we should print the stack is empty. Correct? Stack is empty. And if it is not empty, what we should do? We should then print all the elements. Correct? Else, but to print the elements, we will need some iterator here, right? So let's say int I is equal to what? 0. For loop we will use, because we are going to print all the elements of stack array. So we should basically use for I is equal to 0. I is less than what? Less than equal to. Correct? Top. And then I plus plus. Correct? So the stack would be like this. Let's try to format it well way, right? That's why I'm using tab here. So that will be what? Stack of I. Correct? Now let's give a good example, a good message here maybe, right? So stack elements are. Correct? So this is how it is going to be. So it will basically print all the stack here. So this is going to be display. Now see, we have developed almost a code of 142 lines, right? Now let's see what is case 0. Case 0 simply should basically be nothing, right? It should be exit. But do we should write here? No. But see, one thing can happen. This will only enable you to maybe do one operation only one time, right? But what if you want to perform it like multiple times? Let's maybe try to see it what exactly it is, right? When I try to run it, right, it is giving me an error here. Why? Because I'm missing a semicolon here. Next, it is giving me an error here too. Why? It says int size 2, right? Let's see what is the error is. So I'm missing a data type here. This is int, right? What is the next? See, that's how the troubleshooting is. Now it says int. I should not basically give int here, correct? Which is another troubleshooting part. So that's what it is. See, so there were three errors. It is still like this. We should never give the array part here, right? Any other error? Let's look at what exactly. So no errors. Now it ran fast, perfectly fine. So one. Let's say I want to display the stack, right? Four. See what it says. Stack is empty. But the program exited. I cannot do the more operations on this, right? Then how I can enable like this in a loop? What exactly then we should do? We should basically write something here while one, or while let's say more. Let's try to put that this whole switch into the while. Okay, if we try to put this whole switch into the while, what it will become? Now where this more has come from, where this more has come from, we need to write here, let's say more. By default, let's say the value is 1. Yeah, so whenever there is this is 1, it will come down. So we should rather try to write here some logic which will tell what exactly are we going to do, right? Now let's see what it is. Yep. So you should give, we should basically give some option here for user whether he wants to perform the more operations or not, right? So do you want to perform more operations on stack? If it is 0, then no. Otherwise 1 means what? S. Correct. So, and that is something user will enter. So when user is going to enter, he will enter some choice, right? So it is going to be %d, and where it will go into the more. So more is the variable which is going to decide whether this has to be repeated or not. Correct. So let's try to see now if it permits the multiple operations. Now when I try to run it, it will give you console like this. Now we have the menu. Push an element to the stack, pop element to the stack, size of the stack, display the stack. Now let's try to first display the stack, right? 4, its a stack is empty. Now it did not come out, it did not exit the, it is, do you want to perform more operations on the stack? I says yes. So it is going to give me again the thing, right? Now I will push the element, right? Let's say if I want to push the element, I entered the 1. When I enter 1, it will go and basically it will ask me what element you want to insert. Correct. Now let's say I want to insert the 13 element. So I inserted. Now the stack has one element. Now do you want to perform more operations? Yes. Now let's try to display it now. 4. See. So the stack elements are what? 13. See. Do you see? One element is there. If you want to see the size of the stack, see. So the size of the stack is going to be, stack size is 1. Right. Now let's try to enter more elements. Right. I want to continue, and then I basically want to perform more operations on it, right? Let's say I want to push more elements. Let's say 34. Let's say I want to perform more operations. I want to push more elements. Let's say 56. Now I have entered 3 elements, correct? So if you try to display the stack, it will say 13, 34, and 56 we entered. So that's what the display. Now if you want to see the stack size, you will see the stack size is what? 3. Now let's try to pop the element. When you pop the element, the top is actually pointing to 56. So it will pop the 56 and then stack size will become only 2. Correct. Now let me maybe try to pop it, right? When I say 2, it will give me, like, see, the element removed is what? 56. So the 56 is removed. Now only remaining was 13 and 34. So if I now try to print the stack, it will say only there are two elements. Correct. Now let's try to see when the stack is full, what will give. So we'll enter all the five elements, right? Enter the elements minus 34, right? And then 1. Again, enter the element, let's say 90. So the four elements are done. Again, enter the element, let's say 89. Now all the five elements are done. That means what? Stack is full. Now let's try to enter the element. See what it says: overflow, stack is full, new element cannot be added. That's how the conditions are basically in a stack. Okay. Now let's try to display it. When you try to display it, right, it will say these are the five elements are there. The 5 is the size which we have defined as a maximum size of the stack, right? Now if you want to see the size of the stack, it will basically tell you the size of the stack. See, size of the stack is 5. Now let's see if we delete all the elements from the, if we remove all the elements, right? Let's try to remove all the elements. Pop. See, the very first element removed is what? 89. Then again pop. Very next element removed is what? 890. Now when you now try to display it, right, it will say there are only three elements. Then you should be easily able to push the element, right? Let's say now if you want to push it, you will be able to push it, and then when you want to display it, right, it will basically display the four elements. Now let's try to all remove all the elements. Removed, 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 right? Now 13, this all the elements are removed. Now when you try to remove it, right, it will say enter flow, stack is empty, an element cannot be removed. Okay, I'm just coming out of this. So this is how you can implement the stack using the static part. Yeah, let's go back to the slides. Yeah. So the dynamic implementation we'll see in the next video. In this video, we're going to cover on the static implementation. For dynamic implementation, you need to know the linked list. Once you know the linked list, then we will go for the dynamic implementation. Okay. So what is that? So time complexity of the stack operations. If you look at the time complexity of push, that is big of 1. Pop, big of 1. Is empty, big of 1. Size, big of 1. What are the other variations of the stacks? So stack is basically used to infix to postfix stack, right? This type of stack is used to convert the infix expressions to the postfix expressions. Evaluation stack, expression evaluation. This type of stack is used to evaluate the postfix expressions. Recursion stack. This type of stack is used to keep track of function calls in a computer program and to return the control to the correct function when the function returns. Memory management is also kind of done using the stack. Balance parentheses, right? Whatever parentheses are you using in your expression, everything is basically, or instruction, everything is basically taken care using the stack. Undo and redo, all those operations are basically taken care using the stack. Now what are the applications of the stacks? Infix to prefix or infix to postfix, then undo and redo operations, then memory management, then string reversal is also done using stack, function invocation is done using the stacks, then graphs are taken care using the stacks, trees are also taken care using the stack. Okay, and then the recursion is also basically taken care in the backend, it uses stack only. So in next video, we will look into the queue and the static implementation of queue we will perform practically, right? Live coding. And then once stack and queue as the static implementations are done, we will basically go for the linked list, which is a dynamic implementation of the data structures. Then in that we will see linked list, we'll see how stack and queue are also to be implemented using the linked list, right? So guys, if you like the video, please make sure that you subscribe to the channel to get updates about the new videos, as I'm not going to be limited only for data structures too. I'll be putting Python, Java, right? The things are going to come as and when actually I get time. But yes, do like the video, do share it with the other students as well, so that everyone gets more familiar about or knowledge about what exactly this data structures are, right? And then I wish you happy learning with the GravityTech. Thank you.